Good morning, all. So we will start with whose complement arithmetic. Is my screen visible? Is my screen visible? Okay. Okay. So we'll see. Two's complement arithmetic. Generally, this terminology or two's complement method is used in generally subtraction. As I already uh, told you, that why to use a different circuit for subtraction. You can use adder for subtraction purpose in case of digital logic, right? So that is one reason. Another is this method is quite easy. You can, in case of digital circuit, no, you can use this addition rather mechanism for you can say subtracting two numbers, right? So I'll give you one example for this two's complement method. Say those are two numbers which are there. You need to subtract 7 minus 5, right? Or 5 from 7. What could be the result for this is, it's simple, right? 2 is the result. But how to rather use uh, two's complement method is, first and foremost thing for uh, this two's complement subtraction or two's complement in two's complement arithmetic, you need to find it out binary equivalent, right? Binary equivalent. So what all binary equivalent for this is, for 7 it's 111, and for 5 it is what is the binary equivalent for 5? 101, right? So yes, 101. Now what we need to do here is, in case of two's complement arithmetic, see 7 is called as manuend, whereas 5 is called as subtrahend, right? So it is quite a difficult word if you see when you say that first number and second number, or the sub number which is going to subtracting from first number. In that case, you need to find out two's complement of that number, right? So this is your binary equivalent for 5. You need to find two's complement of this number. What is two's complement, or how you can find it out two's complement? First thing is, you need to find out one's complement. One's complement is reversing all bits, 1 to 0 and 0 to 1, and then adding 1 into it, right? Adding 1 into it. That is 0, 1, 1, right? So this is basically a two's complement number, right? For uh, subtrahend or second number, right? Now, what is second step is, now add that number into first number. What is first number? First number is 7. That is 1, 1, 1. Add this number into first number. What is your two's complement of 5 is 0, 1, 1. Now add this two's complement number into first number. Now, what is addition? What is addition? 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. 0 plus 1 is 1. Right. Now 1 plus 1 is 0 and carry 1. Right. If carry is generated, in this case, concentrate on my words. If carry is generated in this case, discard that carry, and whatever result you get from this addition is corrected and it's in correct binary form, right? So you need to find its equivalent decimal number. Now what is equivalent decimal number for 010? Yes, what is equivalent decimal number for 010? Exactly, it is 2. So the number is 2, right? So if carry is generated, the result is positive and you need to discard that carry and keep that number as it is because the result is in corrected binary form. So if you want, you can convert that binary number into equivalent decimal number, right? So this is about, a simple arithmetic which is there in two's complement method. Now, okay. Uh, okay. Now the case is different, right? This is the example. Now consider 5 as first number and 7 as second number and try out this. Okay. So I'll repeat the process again for you. First, you need to convert those numbers into binary equivalent. 5 is 101, 7 is 111. Now, second method for this is find out two's complement of second method. Now, one's complement is 0, 0, 0. Two's complement is adding 1 and 2. It is 0, 0, 1. Right? Adding 1 and 2. Now, this 0, 0, 1 is in two's complement form and it is two's complement of 7, right? Now what we need to do if we find two's complement of second number, next step is we need to add that two's complement into first number. So my first number is 5. I need to add two's complement of 7 into this number, right? So what is the next step? What is the next step? 1 plus 1 is 0. Carry 1, right? 1 plus 0 is 1 and 1 plus 0 is 1. Now the result is 110 and carry is not generated. Now again concentrate on my words. If carry is not generated in case of this two's complement method, then this number or the what we say subtraction which is there as a result is negative. If carry is not generated, then the result is negative. binary form, right? Result is in 2's complement form, right? So result, if the result is in 2's complement form, again, to find out a correct binary form, we need to convert that result by using 2's complement method. So we need to find out 2's complement of that result, right? So the results 2's complement form is, see, we need to find out first complement. One's complement is 0, 0, 1. We need to add 1 into 8 to find out 2's complement. That is 1 plus 1 is 0, then 0 plus 1 is 1, again 0. Now this is our exact result, which is there in true binary form, and give the sign negative to that. Now convert this number into its equivalent decimal and give a sign to that number as negative, since it is a negative number because carry is not generated, right? So this is how you can do arithmetic, two's complement arithmetic. Till now it's clear. Till now it's clear. Okay. So I'll give you one example. We'll solve this 23 minus 48. Okay. I'll give you 2 minutes, 3 minutes. Just solve this example. 23 minus 48. If you find any query while solving, just put it in chat box or unmute yourself and tell me. Okay. Okay, result should be minus 25, right? If the sign is negative, that means carry should not be generated, and the result which is there is in two's complement form and not a true binary form, right? It's in two's complement form. So you need to find two's complement of that result, then only you'll get 25 as a result there. So what first step you need to find out binary equivalent for 23 and binary equivalent for 48, right? So if you find out binary equivalent, then you need to go for two's complement of second number, right? ओके तुम्ही नोटबुक घेऊन बसलायत ना रे सगळे नोटबुक वरच सॉल्व करताय ना ओके ओके ते सॉल्व करा नेक्स्ट इज ऑक्टल नंबर सिस्टीम आय थिंक मी चालू केली होती काल ना ऑक्टल नंबर सिस्टीम मधलं काय झालं होतं काल ऑक्टल ऑक्टल टू डेसिमल कन्वर्जन सांगितले होते ना आय थिंक ऑक्टल टू डेसिमल कन्वर्जन्स अँड डेसिमल टू ऑक्टल कन्वर्जन सांगितले होते येस नाव ऑक्टल टू बायनरी see 23 is octal number. How to convert it into binary is we need to find it out. Hmm? What we need to find out? The exact binary. Yes, not grouping. We need to find out. Yes, we need to find out 3-bit binary, right? 3-bit binary. So how octal conversion is rather octal counting कसं होतं माहिती आहे का? Octal counting. Hmm. How many symbols are there? How many symbols are there? Total 7, right? So the counting is like 0, 1, 2, sorry, 2, 3, 4, 5, 6, 7, right? After that, you start with next symbol, right? 1, 0, 1, 1, 1, 2, 1, 3 till 1, 7. Again, 2, 0, 2, 1, and likewise, right? So it only has 7 symbols, so you need to count in that order only, right? So this is how you actually count octal numbers. So in case of binary conversion, you need to take uh, binary equivalent. See if this is octal numbers, binary equivalent with 3-bit, right? 3-bit binary equivalent, right? 000, 001, 010, 011, 100, and likewise till 7, right? And after 7, it's 10. So 001, 000. Likewise, the counting is going on with octal and binary. So while converting into binary, you need to find out exact 3-bit equivalent binary number for that octal number. So for 2, it's 010, and for 3, it's 011, right? So 010, 011 is binary conversion of sorry, this 23, right? So this is how you convert it into octal, rather octal to binary. In reverse case, binary to octal, binary to octal, this is my binary number. Convert it into octal. Now, what we need to do is we need to find out groups, right? If you, yes, set of three starting from this to this three, right? So group should be like 3 bit, right? And next is, yes, but if one or two number are there, then add zeros in front of that and make again a group of three, right? So this is 1 and this is 6, right? This is 16 in case of octal. So this is the conversion from binary to octal, right? So just make group of 3 bits, right? From right to left, right? And if number remaining is less than 3, just add zeros in front of that number, right? So this is how you convert binary to octal. Now, this is the number 51, which is octal, plus 24, which is octal. How you are going to add this number? This is, octal arithmetic. Hmm? How to add this? See, find out binary equivalent for this. Pi is 101, 1 is 001, and for 24 it is 010 and 100, right? Add those numbers, 101 and 11, right? So this is 7 and this is 5, right? 75. This is what I thought. Yes, yes. So this is how you add the number. And for subtraction, you can use this way or two's complement method. Find out two's complement of second number and then add that two's complement of second number into first. The method is same. In this, you just find out a 3-bit equivalent binary for given octal number and then add those binaries, right? So this is how the arithmetic is there in octal number system, right? Now, next is uh, hexadecimal number system. Hexadecimal number system. How many symbols are there in hexadecimal number system? Hmm? How many symbols are there in hexadecimal number system? Yes, 16. So keep in mind that total 16 symbols are there And in computer terminologies, this has very much weighted system, right? This system or this number system has a huge popularity in case of computer systems, right? So this is you can say most usually number system in computers, right? So what all symbols are there? From 0 to 9, and from 10 it is treated to be as A to F, right? Total 16 symbols, right? From 0 to 9 and A to F. Total 16 symbols are there in hexadecimal number system. How it is rather treated as is 0, 1, 2 up to 9 decimal, and then from 10 onwards A, B, C, D till F. Just like decimal equivalent 10, 11, 12, so on till 15, right? So this is how those symbols are there, 0 to 15 or 0 to 9 and A to F, that is total 16 symbols are there in hexadecimal. Now conversions, how to convert it into decimal? Just like this has a base of 16, so whatever bit is there, just multiply with 16 raised to its position, right? So this is how you convert it into what we say to decimal. So I'll give you a number 3A, which is a hexadecimal number. Convert it into decimal. Just try this. No? Try this. Hmm? What is the answer? Position is 0, position is 1. So 3 into 16 raised to 1 plus 3 in, sorry, A. A means 10, right? A into or 10 into 16 raised to 0. So anything raised to 0 is 1, right? 1, that means 10 into 1 is 10. Hmm. 16 raised to 1 is 16. 16 into 3 is, I think, 48, right? So 48 plus 10 is 58. So this is how you convert it into hexadecimal to decimal. So 58 into decimal. Now decimal to hexadecimal, decimal to hex, how to convert this? Just like other systems, you need to divide with 16, right? And whatever remainder, yes, divide by 16, and whatever remainder you will get, just write it in reverse order. Then you will get hexadecimal number, right? Converted from decimal number. And how to convert it into binary, hex to binary? Hex to binary. Yes, grouping. We suppose the same number 3A, 0011, and A is 1010, right? So this is how you convert it into binary, group of 4-bit binary, right? Then binary to hex, yes, simple. You can group four digits of binary. If again the direction is from right to left before radix point of for integer part if that number is a fractional number, right? For it is integer part, and in fractional part the order is reversed, right? In case of hex to binary and binary to hex. Obviously, again, arithmetic is how to add those numbers. If hex numbers are there, how to add, convert it into binary and add those binary, again group those binary numbers into 4 and convert it into hexadecimal number. This is how you can add the, or you can have arithmetic for hexadecimal. And for subtraction you can use 2's complement method, which is the easy way, right? Find out 2's complement of second number, add that 2's complement into first number, you will get the result. Whatever rules are there of 2's complement, you can apply all those rules, right? So this is how you can convert the hex to binary and binary to hex, right? Till now, anyone has any issue, right? Anyone has any issue related to conversion? To binary into 4 bits. Yes, put it in chat now. Anyone has any issue? अरे मी काय बोलतोय कळतंय का? कुणाला काही प्रॉब्लेम? ओके, ओके, इझी आहे, नो इश्यूज. Okay, so we gone through few things over there and okay. So next is okay. Next is BCD. So next topic from your syllabus is BCD. In that, BCD addition and subtraction is there. But before that, we'll see what actually BCD is there, right? So anyone knows about BCD? Yes. Anyone from you knows about BCD? Hmm? Anyone ever heard about BCD? अरे येस नो नसेल तर नाही म्हणा ना पटापट नाही ऐकलं म्हणजे मला पुढे जाता येईल. Okay, okay, that's it. So we are actually talking about codes, right? Codes are nothing but pattern, right? So those patterns are used in computer systems, right? So those codes or patterns are used to represent binary numbers in computer system. There are so many codes or patterns are available, just like straight binary. Then BCD is there, XS3 code is there, gray code is there. As and when your syllabus progresses, you'll get the idea about code and patterns as well. But for this BCD or for this thing, just keep in mind that codes are pattern and patterns, can say, of binary numbers, right, which is used in computer system. So in for you, your syllabus, one code is there, or one pattern is there called BCD, right? So BCD code or BCD stands for binary coded decimal, right? So this is the way binary coded decimal code. Now concentrate on my words. Decimal, right? Decimal numbers are coded. How many decimal numbers is there? 0 to 9. Those decimal numbers are coded in binary pattern, right? Those decimal numbers are coded in binary pattern in BCD code. How it is actually coded? It is a 4-bit pattern or 8-bit pattern, right? It is of 4-bit pattern or 8-bit pattern. But generally, they use 4-bit pattern in huge amount, right? So BCD or binary coded decimal or decimal are coded in binary form in such a way that there is 4 bits for each and every decimal, right? Now, how actually BCD symbols are there? If suppose there are 9 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are converted into 4-bit binary in BCD. So for 0, it's 0000. For 1, it's 0001, 001, 00011, 0100, 101, 0110, 111, 100010. Right. So this is how actually BCDs are encoded, right, for decimal numbers. And how many decimals are there? Total 10, 0 to 9, right? So in this, a 4-bit binary pattern is used for decimal numbers. So this is how actually BCD is encoded. So it is encoding format, right? Where actually it is used, generally this format is used in displays, right? Display. If you want to display something, no, there are digital displays are available. In that case, uh, those things are, you can say, used, right? So BCD pattern is used. How to convert a number into BCD? Just like, I have a number called 123, which is there as what we say, mm, a decimal number. Now, if I want to convert it into BCD, how to convert? Just find out a 4-bit equivalent binary for those digits, which is present in decimal numbers, right? So for 10001, for 20010, and for 30011. So the BCD number for 123 is this, right? So you need to write a 4-bit equivalent binary for each and every digit from that decimal number, right? So this is how BCD works. Now, uh, there are total 9 symbols. Then how you actually write 10 is, see, for binary it's 1010. But for BCD, this 10 is in separate form. This 0 is separate and 1 is separate. For 1, you need to use 0001, and for 0, you need to use 4-bit of binary with 0. right? So this is the difference in between, you can say, binary, and this is BCD, right? So you need to use 4-bit pattern in case of BCD, right? So this is about no overview of BCD. What all things are there in BCD? Have you got the idea about BCD, right? हे समजलंय का? BCD समजलं? Okay. 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 Now, next thing is we will see addition, right? Or you can say a BCD arithmetic, right? Basically, BCD arithmetic. It's basically okay. So what I need to do here is I have two numbers called 7 and 6. I need to add this, and addition is 30, right? So how to add this is hmm, how to add. First thing, what I need to do. First thing, what I need to do. Find out equivalent BCD for 6 and 7. Now, what is a BCD number? A BCD equivalent of 7 is, yes, 0, 1, 1, 1. What is equivalent BCD for 6? 0, 1, 1, 0. Right? Now, what I need to do here is 1. Now, addition. 1 plus 0 is 1. 1 plus 1 is 0. Sorry, carry 1. 1 plus 1 is 0, carry 1, and 0 plus 1 is 1. Now 1 plus 0 is 1. This is how the result comes, right? Now check this result with, oh, with your BCD equivalent. Check this result. आहे का हा pattern BCD मध्ये? Is this pattern available in your BCD symbols? How many symbols are there? Yes, exactly. Yes, no, no. Pattern is not available, right? So what we need to do? Hmm? What we need to do? What we need to do? What could be the next step? Hmm? You need to convert this number into this format, right? Now, why this result is exceeded? Because we are actually using 4-bit pattern, right? If we are using 4-bit pattern, that means how many combinations are there? 2 raised to 4, that means total 16 combinations should be there. From those 16 combinations, how many combinations we are actually using? How many combinations we are actually using? How many combinations we are actually using? in BCD? Not 9. Those are 10, right? Yes, those are 10. From 0 to 9. So total 10 combinations we are using from this. But by rule, it is 4-bit, we can say, um, 4-bit pattern. So 2 raised to 4 is total 16 combinations. From that, we are using 10. So if we want to put all the results into those, no, we need to find out a difference in between, right? So that difference should be added into the result. If that difference, if we added into that result, then it comes into correct form, right? So the difference is 6, right? So the difference is 6. That difference we need to add. That means 9, 10, 11, 12, 13, 14, 15, right? If my result is this, then I need to add 6 into this. That if we add 6, then again 14, 15, rather 1, 2, 3, 4, 5, 6. इथं कुठेतरी ते यायला पाहिजे, right? So what we need to do here is whatever result we get from this, if it is illegal, illegal means it is not in the BCD form. It is binary, but illegal for BCD because the code is or the format is not present in, a symbol is not present in given BCD symbols, right? So if that number is illegal, then you need to add 6 into it, and 6 pattern is 0, 1, 1, 0, right? 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1. Keep that carry as it is, right? Now, this is a 4-bit number, and again carry is generated. Append or add 3 zeros in front of that carry and generate a 4-bit different binary, and the result is again a different 4-bit pattern. So this 4-bit pattern gives you 3, and this 4-bit pattern gives you 1. And this is your actual result, right? So how BCD is converted if result is, so in the rule, if result is illegal or carry is generated, then you need to add 6 into the result to get into correct form, right? So हे इथून 6 म्हणजे इथं आलं ते एक्झॅक्टली आणि कॅरी जनरेट झाला. सो 1, 3 that is 13 is your result, right? So this is how you can add the number. तर सबट्रॅक्शन ला काय करतो, ऑब्विसली टूज कॉम्प्लिमेंट मेथड वापरू शकता तुम्ही आणि त्याच वेळी ऍडिशन करू शकता. परत तो रिझल्ट करेक्टेड फॉर्म मध्ये नसेल, आता इलिगल फॉर्म मध्ये असेल या बीसीडी मध्ये बसत नसेल, तर त्या केसमध्ये सुद्धा 06 you need to add into the result which is there after addition. So this is how you can do the arithmetic for BCD, right? Okay, for today we'll stop.